Welcome class, myself Professor D.S. Rai, Professor, Department of Civil Engineering, BBD, ITM Lucknow. Today we will cover course KCE 064 Foundation Engineering, in which we will cover today in lecture 36 Design of Reinforced Earth Part 1. The references that I have taken: Dr. V.C. Punamiya, Soil Mechanics and Foundation Engineering; V.N.S. Murthy, Soil Mechanics and Foundation Engineering; Alam Singh, Soil Mechanics and Foundation Engineering. Some part have been taken from NAPTEL and some material have been taken from internet. The contents that we will take up today, that is work example, design consideration, design of reinforced soil wall having a grid and a strip type reinforcement. So, first of all we are going to cover a work example. It is from the NAPTEL. The design a strip footing to carry a line load of 1700 kilonewton per meter. Data for a design is as follow. The soil parameters that are given in this work example: C is equal to 0, F is equal to 35 degree, Z is equal to 17 kilonewton per cubic meter. Then ES, elastic modulus, is 30,000 kilopascal and Vs 0.35. Again reinforcement parameters are Fy 2.5 into 10 to the power 5 kilopascal. Then phi mu is equal to 28 degree, Fsy is equal to 3, Fsf is equal to 2.5, and the width of tie is given here, that is 75 mm. LDR, linear LDR is equal to 65%. The depth of foundation is 1 meter and permissible settlement is 25 mm. Design life is 50 years that we have here. So, we have to go for that is first of all we have to go for LDR, that is the linear density ratio of reinforcement. Linear density of reinforcement is given here as 65%. So, let us suppose a width of footing is B is equal to 1 meter and depth to top reinforcement layer mu U is equal to 0.5, vertical spacing delta H is 0.5 meter. Now, number of reinforcement that we have taken here, N is equal to 5, LDR, that is linear density of reinforcement, is given 65%, already given in the question, that is W into NR, that is LDR, and that is equivalent to NR is equal to 0.65 divided by 0.075, that is 8.67 per meter. So, 8.67 number of ties will be present in each layer per unit length of a strip. Now, bearing capacity of unreinforced foundation, then QU is equal to, that is given here, gamma dF into NQ plus 1 by 2 gamma BN Ing, it is given. So, for the soil property, F is equal to 35 degree, NQ is equal to 33.3, Ng is equal to 48.03, Q is equal to more or less, that will be 975 kilopascal. And for QS, means considering the factor of safety of material, we can 975 divided by 3, it is given in the question. So, that will come 325 kilopascal. So now come to the settlement. Settlement of a strip footing is delta is equal to QNP divided by ES, elastic modulus, 1 minus mu square, that is the Poisson's ratio, into IF. So substituting all these values and influence factor if of 2, QNP is obtained as 329 kilopascal. So as QS is less than QNP, Q all will be equal to QS will be equal to Q0. So that will be 325 kilopascal. So determination of applied pressure on the reinforcement Q will be equal to 1700 divided by 1, means width that we have considered, that is 1700 kilopascal. The reinforcement force will be TD, that will be given here by this equation, and the tie force can be estimated using the above equation for each layer. So this is the layer 1, 2, 3 up to 5. This is the different value 275. This is Z M in meter when depth of foundation. This is the Z by B, JB, IDH it is given. So JB minus IDH and TD means the forces, tie forces we can get from here for each layer of the reinforcement. Is it? So resistance forces of tie in pull out, that will be given by the FZ is equal to 2F LDR M Z by B into B Q0 into Q by Q0 plus gamma A0 and X0 Z plus D. Here A0 is the length measured from the center of the forces, stresses, vertical stresses to the stresses, 1% stresses of the total stress. So that will be the L0. X is the variables. So we can get the quantity like 2, 10 M, LDR M, this is the different parameters, and finally we get different parameters for each layer. We can get it here. So the minimum factor of safety against pull out of 2.5, it is given in the question, is achieved by all layer. So thickness of tide T will be equal to FSY Tn in divided by LDR Fy. So substituting all these value in the above equation, we can obtain the thickness of different layer as layer 1 T1 will be 1.15 millimeter, layer 2 1.27 millimeter, layer 3 1.4 millimeter, L4 T4 1.4, T5 1.4. As per BS 8006, the corrosion loss on each phase for 50 years life, service life is 1.35 mm on each phase. Hence, the above thickness value should be increased by 2.7 mm, double of the one side. So the minimum length of tide should be equal to 2 into L0. So now layer 1 has a length 3.1 meter, layer 2 5.2 meter, layer 3 6.8 meter, layer 4 7.7 meter, layer 5 8.4 meter. If the foundation soil is unreinforced, the width of the concrete footing should be at least 1700 divided by 325, that will be 5.25 meter. As the above footing increases, its thickness will also increase. So this is a small work example that we have covered here. So now come to the design of reinforced soil wall having grid and a strip type reinforcement. So following are the steps in carrying out the design of reinforcement soil wall having grid and a strip type of reinforcement. So given data will be height of wall, that is h, wall fill between wall and the backfill. So here the wall fill properties of the soil will be gamma 1, C1, phi 1, delta 1, gamma S1 and gamma B1. So this is the parameters for the wall fill soil. Now backfill properties have gamma 2, C2, gamma 5 by 5 to gamma 2, gamma S2 and gamma V2. The position of water table is SW. Loading on the wall, that is QF V1 DBE. Loading of backfill, that is Q. The seismic coefficient is alpha H and alpha B. The type of reinforcement and its tensile strength is RT. Allowable soil pressure is QA. It will be given in the question. So first of all, we have to compute the earth pressure coefficient using backfill property. So Ka we can get by this equation. Putting the value, we can get it. Here delta 2 is 2/3 of the internal friction. So Ka dash coefficient of active earth pressure for the static case for the soil below water level, it is obtained by using delta 2 by 2 that I have already told. So we can calculate this one by gamma S1 10 to minus 1, gamma S1 divided by gamma S1 minus 1, alpha V divided by 1 plus minus alpha V. So the value of K and Ka dash should be computed by using plus gamma B or minus gamma B separately. Adopt higher value of KAD and KAD dash for the further design. So now we have to compute the value of PAY, PAQ, PAC, PW, PTST, MAY, MAQ, MAC, MAW, MST with equation below that we have. So first of all, we have to compute Ka, then Ka dash using this delta 2 by 2 in place of delta. So it is important. Now can calculate the value of PAY, PAQ, PAC, PAW. So the total static earth pressure, that is PTST, will be equal to PAY plus PAQ minus PAC plus PAW. So this is the forces. Now come to the moment of a static earth pressure about the base. We have to calculate it. Again, this is the MAY. Putting the different value of parameters we have in the equation, we will get the value of MAY, MAQ, MAD, MAC and MAW by putting the value of different parameters in the equation. Finally, we will get the total moment about the base will be MTST will be equal to MAY plus MAQ minus MAC plus MW. So, this is the static case that we have. Now come to the dynamic increments. Dynamic increments, the dynamic increment have been computed as per procedure given in IS 1893 1984. According to this code, the distribution of the ratio of lateral dynamic increment due to backfill swell only to the vertical effective pressure. So, this is the figure we have, that is 3 KAD minus KA. This is the value of Z, this is the height, this is the SW. So, KA dash and the value of KA and KAD can be computed in the submerged conditions also. So, here we can put the value of each parameters, we can calculate MAQ, MAC, MAW, and the total moment about the base will be MST, that will be equal to MAY plus MAQ minus MC minus MAW. So, now we have to compute this PAYA, PAQI, MYI, MAQI. So, we have to calculate this one. So, now this is the PAI and this is the formula in which we have to put the value of different parameters given in our question. So, we can calculate the value of PAI, PAQI, PAY, PA gamma I, PAQI. This is the equation in which we have to put the value of different parameters for calculating the different parameters required. So, now we have to go for assuming a length of a reinforcement, and length should lie between 0.7 to 0.09 h. Now compute W, W dash W, MW, M dash W, Q, MQ, MSWH, MSWV, MQH and MQV with the following equation. These are the equation for calculating these all parameters, and we have all parameters given in our questions. So, we can go for this one. So, here the weight of the wall, we can consider it, the effective weight of the wall, the moment of weight of wall about the toe, then the surcharge forces on the wall, then the moment of surcharge force about toe, then considering the seismic force on the weight of the wall. One is for the static condition and another is for the seismic condition. So, here the seismic forces on the weight of the wall, the horizontal seismic force will be W into alpha H, and for the vertical forces that will be plus minus WW into alpha V. So, the moment of the seismic forces acting on the weight of the wall, we can calculate the MS M SWH, M SWH, that is M SWV. Now horizontal seismic forces, that is given here. Vertical seismic forces we can give here like this way. So now again moment of seismic forces on the surcharge acting on the wall about the toe. So M SQH will be Q alpha H into H, and again M SQV will be equal to plus minus Q alpha V L by 2. Now come to check the external stability. For the external stability, we have to go for computing Fs and F0. For the static case, we have Fs is equal to mu W dash W plus Q divided by P TST. That should be less than 2. Again, for the seismic case, Fs will be equal to mu W dash W plus Q plus minus mu W plus Q into alpha V divided by TST plus PAYA plus W plus Q into alpha H. After the computation, this should be less than 1.5. So, if either of the condition is not satisfied, increase the value of L and repeat the above all process. Now compute sigma maximum and sigma minimum. For this one, we have to go for tilting and bearing failure, considering the tilting and bearing failure. So we have a static case in which this is the sigma maximum and this is the sigma minimum. That should be, sigma maximum should be less than QAA. And sigma minimum should be less than 0. In the seismic case, the net moment about the center of base of the wall, that is MTN will be equal to MTST plus MA gamma I plus MAQI plus MSWH plus MSQH. So here sigma maximum again should be more than 1.5 here. That should be more than 1.25 QA. After putting the value of each, we can calculate this one. And sigma minimum should be like this way, or we can calculate it, and that should be less than 0. So here is the conditions. QA is given is the allowable bearing pressure of the soil base. If any of the above condition is not satisfied, then increase the length first and redo from the above step again. In case of a vertical and horizontal line load, Fs, F0, sigma maximum and sigma minimum will be computing using this way. For the, we can go for the external stability. So this is the static case, again this is the seismic case. For overturning, this is the static case. That here in a static case that should be less than 2. Here for the seismic case that should be less than 1.5. So it is different. So overturning, if F0 should be less than 2 and for the seismic case S0 should be less than 1.5. Now tilting and bearing failure, we can calculate sigma maximum and sigma minimum, and that should be less than QU, or the Q minimum should be less than QU. So for the seismic cases, we have to consider again MTN, and that should be that could be calculated by using the different parameters in this case, and sigma minimum we can calculate this one, and that should be less than QU. So the sigma minimum should be W dash W plus Q plus V1 plus minus W plus Q into alpha V divided by L minus MTN into 6 by L square should be less than 0. So we'll continue this design consideration in the next lecture also. So thank you very much.